Hi guys, it's Miss DeLitto. We're going to take a look at the distributive property today. So we can use the distributive property to simplify or expand expressions and write equivalent expressions. We're going to take a look at this both algebraically and using a visual representation. And we're going to start with using that area model. So we're going to write some areas of rectangles as a product of length times width and as a sum of the two areas of the smaller rectangles that's making up the bigger one. So if we look at rectangle number 1, again, we know that the area of a rectangle is equal to base times height or length times width. If we were to write an area of this as a product, we would take our base and multiply it by our height. We know that our height of this rectangle is 5, and our base is whatever x plus 7 is. So we have x plus 7 as our base and 5 as our height. So we would write this as a product as 5 times whatever x plus 7 is. That would give us the area of this rectangle. We also could write the area of this rectangle as a sum. And in this case, we can find the area of the two smaller rectangles and add them together to find the area of the entire rectangle. So the area of this first rectangle I would find by taking my height of 5 and multiplying it by the base of x. So 5 times x, or 5x, would be the area of my first rectangle. I would find the area of the second rectangle with my height of 5 and my base of 7. So 5 times 7, or 35. So to find the area of this entire rectangle, I would add the area of the first rectangle, 5x, to the area of the second rectangle, which is 35. So I would write my area as a sum as 5x plus 35. Let's take a look at another rectangle. So in this rectangle, my height is -2, and my base is 3m plus 4. And we need to know that entire base before we can actually multiply it by the height. So our area as the product would be my height of -2 multiplied by the base of 3m plus 4. So we have our base times height here. To write this as a sum, I'll do the same thing. I'll find the area of each of the smaller rectangles and then add them together. So our first, we'd have -2 times 3m, which is -6m is the area of that first rectangle. And then -2 times +4 would give me -8. So my area as a sum, I would take my area of the first rectangle, -6m, and add it to the area of the second rectangle, which is -6m, or -6m plus -8. Or I can write this as -6m minus 8, since these are the same. Either of those would work. So what does this have to do with the distributive property? Well, the distributive property allows us to multiply each addend separately and then add their products. The distributive property really expands an expression. So let's take a look at what this means with each of those rectangles. So rectangle number 1, the area as a product was 5 times the quantity of x plus 7. So this distributive property allows us to multiply each of these addends by our height separately. So 5 times x, which is 5x, and 5 times 7, which is 35. So we've multiplied each addend separately, and then we add their products, or the answers we got, together. This gives us that area as a sum. Same thing for rectangle number 2. We can multiply each addend, each of these things we're adding here in the parentheses, separately. So -2 times 3m, which is -6m, and -2 times +4, which is -8, and then we can add those together. And again, that gives us our area as a sum. So mathematically, and generally, the distributive property really tells us that when you distribute something, you give that thing to every person or everything in the group. And in this sense, our group is what's inside of those parentheses. So to distribute in math, we multiply each term inside of the parentheses by the term outside of the parentheses. So we'll take a look at this and I'll show you some strategies that you can use to help you with this. So I'm going to show you, we can draw our rectangle area model and use that to help us because that is always very safe. And we have the expression 3 times the quantity of x plus 5. So we know from our work above that this is our area as a product. So we know this number here is our height. 3 is our height outside the parentheses, and our base is x plus 5. And I'm going to keep that plus sign in there. We'll talk about why shortly. Now that I've set up my rectangle, we can go through this 2 different ways. So again, we know that we're now trying to write our area as a sum. So we can find the area of each rectangle individually. So 3 times x is 3x, and 3 times positive 5 is 15. And then we can add those areas together. This is the same as if we mathematically multiply everything outside the parentheses by everything inside the parentheses. So 3 times x gives us 3x, and 3 times 5 gives us 15. Again, those arrows are super helpful, and make sure that we multiply by everything inside of those parentheses. Let's take a look at our next one. So in this next one, I'm going to do the same thing, but I'm not going to use the boxes just to show you what this looks like algebraically. Again, the distributive property allows us to multiply each addend, each thing inside the parentheses, by the number outside. So we can take negative 2 and multiply it by 4m, and we get negative 8m. And then negative 2 times positive 1, which gives us negative 2. And we know we can add those 2 things together. So we have negative 8m plus negative 2. Or I can write this as negative 8m minus 2. Let's take a look at the last one. And for this one, I am going to draw those boxes again. So I'm going to set up those boxes. Again, I know my height is going to be the number outside the parentheses. And then 6x minus 12 is going to go up here. So again, I want to make sure that whatever's inside the parentheses reads across my rectangles here. Now I can go and find the area of each rectangle. So 1/3 times 6x, and I'll show it algebraically at the same time, gives us 2x. And then 1/3 times negative 12 gives us negative 4. I can now simply take whatever's inside my rectangle and write that as my simplified expression, or I can add those 2 areas together, 2x plus negative 4. Either of those answers would work in this situation. I encourage you guys to use those rectangles to help you. Again, when we're writing our area as a sum, that is our distributive property. Or we can think of it algebraically where we're multiplying everything inside the parentheses by the number outside. Just pay careful attention to those signs.